These are three lovely lights, but this one recently stopped working. Let's try and figure out why. Here are the LED specs. Let's just have a little look at them. I'll see if I can zoom in a little bit so we can see. So high quality LED bulbs suitable for home or office use, check. Comparing with incandescent bulbs, it can save over 90% of electricity cost. Well, that seems reasonable. 30,000 hours lifespan. Yeah, I think I want to debate about that because this one has only been in the job for probably 3 months and is not on. Well, it's on hardly at all, really, for probably at the very, very most, an hour a night. Yeah, and even that's stretching a little bit. It says no liquoring. Okay, good. No UV radiation. Okay, well, that would be interesting to test it. You can usually test that. In fact, I've got some UV testers coming, so yeah, maybe we'll check that. No mercury. Okay. Easy installation. Check. Using high quality using high quality LED, high quality power driver, instant full light, operate in outside temperatures, and it's an IP45 protection. Okay, so 360 degrees, 280 lumens presumably, and 30,000 hours, not true. And then it says energy requirements are quite low. It has an unusual connection in that you plug it straight in to the 240 volts, and it's got these sort of two little wires here. I'm not really sure what you would call that. It probably says somewhere what format that is. I'm not really sure of that. But I think I can see in there that looks like a problem with some arcing there. So that may be the reason why it died. And what I want to do is actually have a look in there and see if any of these LEDs are recoverable, because why not? But also if I can maybe have a look at the DC side of this circuit and get it going again. And even if I can replace that chip which looks burnt out in there, maybe even plug it back into the AC side. I mean, part of the problem with the AC around here is, well, it's across Australia in general actually, is that we have a lot of solar panels on people's roofs, and because we're pretty much, don't kill me for this one, but pretty much a third world country when it comes to technology, we don't compensate for that, and so your voltage levels can be quite high. So 240 volt nominal, but you can read 265, and that's just going to blow away your white goods and your LEDs and all that sort of stuff. So that is a bit of an issue. But let's get it open and see what's inside. Okay. Oh, that's satisfying. That's a satisfying noise. Come on. Not giving up its secrets easy, which is probably a good thing. 240 volts and all of that. Oh, okay. So we are getting pretty close now. And we are, oh yes, look at that. Yeah, let's clean this up and get a bit closer. MB10F. Most likely the rectifier, I would say. Hard to say whether it's intact or not. Let's get a bit closer to these things. Yeah, that doesn't look well, does it? Like there's been some arcing or something. And we've got a resistor there, which is 684. And then on the other side, we've got EG 1000E, and it also says 4NRY. I presume that's some sort of LED driver. And we've got a, what is that, 43R0 and 2 possible spots to put that resistor in. So there's some pads underneath that. I think I'm just going to see if I can get this to light up by playing with the DC side. I've got no joy in applying a voltage to any of those points. So I'm just going to pull one of these guys off if I can. And of course, whatever fried the board could have fried every single LED on it as well. These are sitting pretty firmly on pads, and so I have tried to activate those pads. I'll actually try sliding here. These are pretty well on. Yeah, I have tried to activate the light with the pads that are there, but yeah, they're not behaving themselves. So let me see how this is going. Nothing's coming off. Of course, if shorting them out at high voltage doesn't work, then cooking them at 300 degrees should work, right, to kill them. So yeah, these aren't even thinking about coming off. Whoa, having said that, pop. Nice. Okay, yeah, you can see the pads underneath that. All right, let's put some voltage on that and see what we can get. Of course it broke in half when I was trying to solder up a resistor to it. Let's try and get another one off. Well, I pulled the few off on one side. Some went flying across the room. I've just put a resistor on this one, and we're going to give it 5 volts and see what happens. I don't know which side round is which. Yep, nothing. No current registered either. Let's turn it around. Nope. Okay, so let's give it a little bit more juice. I mean, 5 volts should be enough, shouldn't it? Let's try 12 volts. 12 volts this way around. Nothing. I have got it current limited. 12 volts the other way around. Nothing. Yeah, look, I'm pretty sure that whatever short happened here, whatever damage has happened, probably fried the whole lot, I would think. And even the process of removing them at 300 degrees might have played a part, but this is one dead light. A little bit of fun to play with. I'd have to say that is not the circuit working for this week. I'll see you next time.